Hi Bio30. Last topic for chapter 17. We're going to look at pedigrees and how those are drawn up to trace genetic disorders through generations in a family. So a couple of terms here. Selective breeding is when mostly in agriculture, in plants and animals, desirable traits are chosen, and those will be used as the parents of the next generation. And this is basically genetic manipulation, but it's a way that the desirable traits are sort of refined over many years of breeding. And you can see what happened with the ancient corn and how it was actually started out like this little guy, and they kept breeding for longer ears of corn with bigger kernels, and we went from basically having corn that looked like this to what we have now, full ears of corn. So it's an interesting example of selective breeding. With canola, we also look at this because it is a Canadian story. In Saskatoon, scientists found a way to breed the canola plants to get rid of the toxic components of it. And so when they were able to do that, we have canola oil, which is high in unsaturated fat, so one of the healthier oils. And these breeding animals, we breed them to have more and more milk, maybe poultry to have less cholesterol in their eggs, beef to have leaner cuts of meat. This is one of my favorite videos called the Super Cow. Check this out on the PDF version of our notes, of our PowerPoints. Not the PDF, sorry. Check this out on the actual PowerPoint because the links will work. Alrighty, pugs, take a look at the dog link if you're interested in that. And that brings us to the pedigrees. If you were to do the diploma, you would have the pedigree symbols in the data sheet. So you don't have to memorize those, but it's useful to just know which are male and female and how it works. But basically it's we drop a pedigree out of several generations in a family to look at the inheritance pattern and see what the mode of inheritance is. And there's basically 4 different possible modes of inheritance, and you guys will be able to tell what they are very quickly as we look at pedigrees here. Males are the square ones, and I should get a darker color for this. Females, the round ones. The ones who mate and have kids are connected with a line. If they are close relatives, 2 lines. That sounds maybe kind of funny, but historically, if we look at like royal families, often that was encouraged to preserve the blue blood, royal blood in the family. So that's why some pedigrees may have that. A Roman numeral will symbolize a generation, starting with 1 at the top, the oldest generation, and next generation. And basically these two who have kids, they're connected, and their kids will be indicated in the order they were born. So first child, second child, third child. And these are the regular Arabic numbers, and the Roman numerals are for the generations. Okay? Twins will be connected if they're identical, still connected at the point if they're not identical. This is the important one here. If we have affected individuals, they will be shaded, and that is the way that you know which individuals in the whole pedigree are ones that have the condition that you are studying. So it would be a pedigree about one condition. The ones who are shaded are the ones who have it. And sometimes They may show you who's a known heterozygote, but that's very rare that they give you that information. Also rare that they tell you who's a carrier of a sex-linked trait. Those are basically bonus if your pedigree shows you those. Deceased individuals in some pedigrees may show you this slash, and I have personally never seen a pedigree where they have used the symbol of sex unknown, but you never know, it might show up somewhere. So the 4 possible modes of inheritance, the first one is that condition is a dominant condition. And because the possibility is that some conditions are sex-linked on the sex chromosomes, any conditions that are on chromosome number 1 to 22, not on the sex chromosome 23, would be considered on an autosome. So if it's a dominant condition and it's not sex-linked, we could call it autosomal dominant. And you would know it's autosomal dominant if there are individuals in every generation that have the condition. So that's often the way to tell that it occurs in every generation of our pedigree. And also, if you see some boys and you see some girls in there, you know that it's not sex-linked, because if it's sex-linked, it will be generally pretty much all boys who show up with it. So if it's boys and girls, every generation, we're going to say good possibility that's dominant. And we know that any child who has it had to have a parent who had it because it was a dominant condition. And things like polydactyly, extra fingers and toes, Huntington's, Marfan's, these are examples of human dominant conditions. There's some polydactyly there. And you can read about a few of the other incidents of dominant conditions. But I'm going to go on to just show you how we read the pedigree when you see that it's every generation has some dominant individuals, and there's some boys and there's some girls. So for those reasons, we can assume that the shaded ones then are dominant. So we're going to actually write in dominant for all the shaded ones. And the reason I'm writing them with a slash beside it is because at first, unless you analyze more closely, you don't know if it's carrying another dominant gene or having a recessive along with it. We just know that if it's boys and girls, every generation, the condition is an autosomal dominant condition, which means then the ones who don't have it are recessive individuals. And so you might as well put them all in as recessive genotypes. And then you can go and analyze whether you think this would be a gene that's recessive. And the way you know is that if you see that they have a child that's recessive, the only way that's going to happen is if this second one was actually recessive. So that is how you tell, by checking out the genotypes of their kids. Now, this individual, because, disappeared here, because their parent only has the one dominant, the other one is totally recessive. This is the only combination possible. Over here, when we look at this person, because this person had recessive kids, then it's got to have had a second gene that was recessive. So what you're doing is imagining doing this cross here. And when you do this cross, you're like, realize that there's going to be recessive kids possible if it's carrying, if this female was carrying a recessive gene as the second gene. Okay. This person here, we didn't do that one yet, but they got one big A from the mom. So from the dad, they had to get a little A. So there we were able to determine all of the genotypes of the individuals in all generations. That's not always the case. Sometimes there's some that you just leave, dominant ones that you leave a slash beside because you can't really tell if they have what they have as a second gene, and it's okay to leave it that way if you don't know for sure. Okay, so Second possible type of mode of inheritance is if the inheritance pattern is recessive. That is when that condition will skip generations in your pedigree. Remember, dominant, autosomal dominant, it was found in every generation. Autosomal recessive will be if you see boys and girls have it, but it skips generations, then you know it was a recessive condition, like PKU or cystic fibrosis. That's a recessive condition. And basically, there could be affected kids who have that recessive condition whose parents didn't have it because they were just carrying that recessive condition. So you've got to look at that carefully and check that out. But basically, with this one, we can see that this is the only fully recessive ones are found in this generation. We see some heterozygotes indicated here. Very nice for them to tell us that. But because it's only in one generation, the 2 generations before did not have that condition, we know that this is a recessive condition. So we're going to mark the infected people as recessive, meaning every single other one is in the whole pedigree is going to be dominant. And because they came out and showed us which ones are heterozygous, thank you very much. We know what exactly everybody has as their genotype. And so we can fill those all in. Okay, so they were showing us which are shaded half and half, so we know those were heterozygous. And this all works out. These 2 people here, it's very possible when you do their cross, you know it's going to be a 3-to-1 ratio of dominant to recessive, and they have basically 3 kids who are dominant and they've got 2 who are recessive, but it's these hidden recessives that came together to give them a child with that condition, whatever this condition is. So remember, autosomal recessive, you see boys and girls who have it, and it skips a generation. Okay. Type number, well, there's another one, by the way, recessive. We can check that one out. It skipped a generation at the top, so we know that it's going to be recessive here to have this condition, which means everybody else has at least 1 dominant, and they don't tell us who's heterozygous in this case. So I look at this and say, for this child to be recessive, both of these parents have to be carrying the gene. This one, we really can never tell. We don't see who it's married or what kids they have. In this case over here, because they had a recessive kid, we know that this was a heterozygous dad, because these both had to give a recessive gene in order to have this child. In the case of these guys, you know that their mom here was recessive, so that means that their second gene was recessive. Okay, and it's okay to leave this one as dominant plus a slash because we don't know what the second gene is, and that's perfectly acceptable. Okay, and third type of inheritance pattern is when it is sex-linked. You're going to see a whole bunch of boys who have it. If it's sex-linked dominant, if it's sex-linked dominant, you're going to see mostly boys, but you're going to see it in every generation. If it's sex-linked recessive, you're going to see, again, mostly boys, but it's going to skip generations. So simple as that. Some of the conditions found on the X chromosome are things like hemophilia and color blindness and muscular dystrophy, which some of those we talked about in our sex-linked crosses earlier. But have a look at how this looks. Basically, when we check this out, we see that this guy has it and this guy has it, so only males. And we see that it skips this generation. So because it skips, we could say this is sex-linked recessive. Now, if you determine the condition is sex-linked recessive, that means that this guy who has it, you've got to put him in as a recessive on his X chromosome. So if it's sex-linked, you're going to write the XY for guys. And if it's recessive, there's the recessive. I just use A's here. This other guy over here, same thing. He's the one who has the condition. We figured out it's sex-linked recessive. We put a little A there with him. Now, those are the only two who have it. So every other guy and girl, here's a girl, she doesn't have it. You're going to give her at least one dominant. This is a guy who doesn't have it. Give him the dominant. If remember, as a guy, give him a Y. This guy, dominant, give him a Y. This one is a girl. How do I know that she is carrying a recessive? Because of this boy that they had. So that boy had to get that recessive from mom carrying that recessive. She is dominant, because remember, everybody else is dominant, but she was carrying that recessive and gave it to her son. Okay. This is the pretty much, leads us to the royal family here, where we look at hemophilia in Queen Victoria and Prince Albert's family tree here, pedigree. And they didn't write all or indicate every single person in the royal family, because when it says here they had 34 kids and they only mentioned a few in that generation. And this same here, 26 kids in that generation. They only mentioned some of them that fit in this picture. They're mostly profiling the hemophiliac children, just to show you how many there were. So you can see that you see almost all boys, one girl here, almost all boys, and it skips this generation here. So that's why we're going to say that this is sex-linked recessive condition. So if you were to do this pedigree, you were going to say that these boys all have a sex-linked recessive condition, which we know hemophilia is. Okay, and with the ones with a circle with a dot, we know those are carriers. So they're dominant girls, but they were carrying it, and that's how it ended up in their kids. Okay, when they married someone who didn't have it. So remember that moms who carry it often give it to their boys in the sex-linked crosses. Now, as we analyze this, you notice that sometimes with the royal family, the reason there's so much hemophilia is things like this. Henry and Irene maybe were, a little too related to have Waldemar and Henry, who both ended up with hemophilia because Irene was carrying it. But anyway, other thing that my students like to point out is that there is some scandal here in the royal family, and you guys maybe already noticed the scandal, and it would be first baby, little Victoria, now named after her mother. However, even though Miss Queen Victoria is dominant for this condition, and she carried it, as we see in her symbol here, she carried hemophilia, and that's how she ended up giving it to baby Leopold. But even though she carried it, Albert did not have it. So Albert's a dominant. So for Miss Victoria to have hemophilia, Miss Victoria has to be recessive. Now, my friends, is it possible for baby Victoria to be recessive and be the child of Prince Albert? And obviously, that is a no. So Miss Victoria got a recessive gene from both parents. So Queen Victoria had some lover who was hemophiliac, and it wasn't Albert. So anyway, scandals that are the royal family. The fun to look at, and we can check out this one. You guys can try this one out and see the slashes, remember, just for previous generations that are deceased. But in this one, if we were analyzing this, we see the skip here of this generation, so we know it's some kind of recessive. We check it all out, it's all boys, so we're going to guess that it's sex-linked recessive in its mode of inheritance, sex-linked recessive. And so when we put our genotypes in there, we can indicate all the ones who are dark and have the condition as being recessive and sex-linked, because that's what we figured out by checking out the incidence of who has it. They're all boys, and it skips a generation. So you guys can fill those in if you like. And that brings us to a little bit last thing about why this is often done. It's for genetic counseling to look at maybe the possibility of passing conditions in the family and whether it is a dominant recessive condition. So genetic counselors would use that. For genetic screening, they may actually have to look carefully at mapping chromosomes to tell. That would be a more expensive second step to do if they want to examine exactly what the chromosomes carry and if there's a genetic condition on there, especially if some of them are, you know, very debilitating or fatal. Parents may want to seek counseling for that. Anyways, I put a review in here for modes of genetic inheritance. And remember, if it is boys and girls, that means it's going to be autosomal. It's on chromosome number 1 to 22 somewhere. And if it's in every generation, boys and girls, it's autosomal dominant. If it skips a generation, boys and girls, it's recessive. So every shaded one here, if it's dominant, that means that shaded one is going to be dominant if it's autosomal dominant. If it's autosomal recessive, that means every shaded one is recessive. Okay? If it's boys and you find them in every generation, we're going to say those boys must be sex-linked dominant. So we're going to indicate them as so. Whereas if they're boys but skip generations, we're going to say that those boys, if it's boys, but they skip generation, we're going to know that it's a recessive condition and note all of the shaded ones as being recessive. Okay, hopefully that is something that you guys don't have to do that. That's going to be easy to try out. I gave you all the answer keys of the pedigrees that you guys can try mapping out that are in your notes, plus the answers to all of the diploma questions at the end. So try this out, guys. Next thing we'll be doing is our chapter test for chapter 17 and wrapping up chapter 17. So happy crossing, and we'll